Well, hey guys, and welcome to your Week 7 MyStatsLab Problem 7 example. And in this problem, we're going to consider the situation below, identify the population and the sample, explain what P and P hat represent, and tell whether a confidence interval for proportion can be used. So let's look at our problem. We have a medical device manufacturer, and they are checking the production of their blood sugar monitors. A researcher found that 11 devices in a sample of 500 did not meet one of their criteria, quality criteria. How severe is the rejection rate for the company? Okay, so our first question, what is the population? Well, the population in this case is going to be all of their monitors. So all of the blood sugar monitors that the company makes would be the population. So the population is all of the monitors that the company makes. So all of them would be the population. Next question, what is the sample? Well, since the sample is a subset of the population, and these are what we're looking at, for this situation, the sample is the 500 blood sugar monitors that were tested. So our population, all of the monitors, the sample in this case is the 500 that were checked. So in this case, 500. Part 3 of our question, what does P represent in the situation? Well, first of all, let's go back to our question and take a look at it. In this case, we're looking for monitors that would be rejected. So that's what we're looking for. So in our case, a success would be a monitor that did not meet the quality control criteria. So that means a failure is a blood sugar monitor that does not meet this criteria or would be rejected. The true proportion for a population is donated by P. So for this situation, P is going to represent the proportion of all the blood sugar monitors produced by the company that do not pass their quality control. So P is all of the monitors produced by the company. So this would be all that fail. All right, part 4 asks us, what does P hat represent? Well, in this case, P hat is going to be the observed proportion in the sample. Okay, so the failures within the sample. So P hat represents the proportion of the 500 that did not pass quality control. So in this case, we're going to say it will be 11 of the 500. So that would be our P hat. So that leaves us with one more problem. Can a confidence interval for a proportion be used? Well, we have to make sure that we meet all of our conditions to see if a confidence interval can be used. So the first question is the independence assumption. And we can assume, because the problem doesn't state otherwise, we can assume that this data was collected at random. So the first part is yes. The second part, the 10% condition. We have to know that our sample is less than 10% of the total. Well, in this case, there's no reason for us not to think this is a large company that makes a lot of monitors, so it is safe to say that the sample is less than 10%, and we can say yes here also, which leaves us one more, the success failure condition. And we have to have at least 10 successes and 10 failures. Well, remember, we have already stated that in this problem we're looking for failures, so successes would be failures. Well, in that case, we have 11 failures, which is greater than 10, so we're good there. And then we also have to have, let's go back. That means 11, we had 11 successes. Successes being that they did not make that. So we'll say that we had 11 successes, and we also have to have 11 failures. Well, in this case, if 11 were successes, we had 500, so that leaves us what, 489 for that one. So 10 of those also, so we can say yes there. So in this case, all our conditions are met, and we can say that yes, a confidence interval for the proportion can be used. So there you have it. There is your Week 7 MyStatsLab problem example. I hope this helps you with your problem, and we'll see you again later.